All right. So 6.4, processing sentinel values. So it's come up before, so you had questions about how can I keep entering data and then have it stop when I'm entering numbers or something like that. Um, so to indicate that's what's called a sentinel value, or the end of a data set. All right. Often, some people you'll see use 0 or -1, but that could be tricky because that could be a legal value if you're dealing with numbers. So what you actually would want to do, what we're going to do for this demonstration, is, you've seen this before, enter a value or number, press Q to quit. Now, obviously, if it's a string, I can't have Q. I have to do something else. But for numbers, we're gonna do numbers. So let's say we did 1, 2, 3, 4, and then hit Q. That's great. And then it'll stop looping at the Q part. You do what's called a loop and a half. You do the enter a value, and then you just keep looping through until you read a Q, and then you kick out and do some other work. Obviously, the one problem with that is that Q is not a number, right? It's going to throw an error. I can't have my program crashing when they press Q to quit. I want it to stop, not crash. So we're going to have to take everything in. All my input is going to be strings, and then I'm going to convert it. So remember how we convert, so it would be something like, enter a value, string, input equals in dot next. I can't use next int or double. And then if input equals ignore case a Q. That's a terrible Q. And we want to use equals ignore case instead of just equals, because if I put in a lowercase q, I don't want my program to crash either. Okay, if that's the case, then for somehow indicating it, we're done. Else, double x equals double class static parse double method input, right? So change it from, if it's not a Q to quit, change it from a letter to, or from a string to a number I can actually do some work with. Okay, but the problem is that the loop termination occurs in the middle of the loop, not at the end. So I got to try to read input before I can test whether I've reached the end of the input. In Java, there isn't a ready-made control structure for do work, then test, then do more work. So we're going to do a combination of a loop and a Boolean variable. So it's often called a flag, and we're going to just set a Boolean called done, and it obviously going to start out as being false. So while not done, it's very easy to read, because remember my loop keeps going while true, and if done is false, not done is true. So while it's still true, do my prompt, read the input, and then process that input, and keep going. Okay. So this is what's called a loop and a half, because you're doing something, you're getting it started, and then looping. All right, so we're going to look at this data analyzer on page 248. All right. So the analyzer is my main. It gets the work done. This is actually where that loop and a half is. All right, so I have my scanner. I make a new data set, just like the one we had before. I set my flag to false. Okay, well, I'm not done. Ask the user for information. Save it. If it's a queue, I'm done. Kick out. Otherwise, parse it into a double from a string and add it to my data set. Then when that is all done, print out the average and the maximum. All right, my data set should look pretty familiar. It's just the count, the sum, and the maximum one, average and maximum. So I just track my current counter. To get my average, I divide my current sum by the count, and I do my maximum check to see if my number is bigger, and I return the maximum value if asked for. So enter a value, 1, 2, 3, and 4. Q. Average is 2.5 and the maximum is 4. Okay. Now we're going to expand this to my concept from 6.5 of random numbers, which is very important, and coming up with simulations. Random numbers are very easy and somewhat powerful. Technically, there are no true random numbers in a program. It always starts somewhere, and then the sequence of the algorithm will be the same. Better algorithms produce more randomized results. So we're going to simulate what's called, first we're going to simulate rolling a 6-sided die, and then we're going to go into a simulation of what's called the Buffon needle experiment. So don't really worry how it works, but because we're not actually generating a simulation. Obviously, if you're going to generate a real simulation, you'd have to fully understand the problem, but we'll start off with rolling a die, and we'll go from there. But to use a random number, okay, you have to import the random class. It's under util. Alright. And the two that we're going to do, next int, some number n, or next double with no parameter. Okay, so this kind of like substring is a random int from, part of the board's weird, 0 to, that's really kind of bizarre. 0 up to, but not including n. Okay. And then next double just gives me a floating point between 0 and 1, not including 1. It's a decimal, so then I have to multiply it out. So up to between 0 to 1 exclusive, so not including 1. All right, well, how am I going to use that? Let's go look at this die simulator, see if we can understand it. All right, so all the simulator does is has a simple for loop, because I'm not looking for anything to trigger as far as a done flag or some condition. I'm just counting 6 times, so I can do a simple for loop. So I'm going to make a new 6-sided die right here. Number of tries is 10. I'm going to run it while I'm less than or equal to my tries, because I'm starting at int at 1, so 1 try. Obviously I don't start at 0 tries. So while I've done less than or equal to my 10 tries, increment I after the end, call the cast method, and print the value. Okay? So obviously cast is some sort of return. So my die makes a new die with the number of sides as my parameter s, creates a new random, and it's generally called generator, so private random generator, and I make a new random object, and then I cast. Now, next int, alright, so up to the sides. Well, it starts at 0, so if I said 6, it'd give me numbers between 0 and 5, because it wouldn't include 6, which is absolutely useless for a 6-sided die, because I need to have up to the number 6, and 0 doesn't get to count. So what you actually do, if that's the case where you're trying to go 1 to a number, you go up to that number as your random value, and you just add 1 to it. So whatever it gives me, which is going to be legal values 0 through 5, add 1 to it, it's going to give me legal values of 1 through 6. So let's see if that works. So I'm going to get a 6-sided die, run it 10 times. There should be a different set out. 5, 3, 6, okay. 5, 5. Let's see if we can go until it doesn't start at 5. 4, 3, 5. So it's just spitting out a sequence of 10 random numbers. Okay. Now this needle experiment was a little more complex. The idea being I have an angle and I drop a needle on it, and that the needles hit if my height of it's at least 2, and if I do it enough times I'm going to approximate the value of pi, which is kind of bizarre. But I have to generate angles. Alright? So what I'll actually do is I'm going to make my new parameter, hits and tries, depending on it counts as a hit if my height of the is 2. So we would say that we're going to say that the needle is a little bit bigger than that. And then we're going to try to generate a number between that to simulate the so let me get this right. The y coordinate. So the x coordinate is irrelevant. I don't care where I fall on my x number line, but my y coordinate does matter. So we're dropping the needle, and we're generating two random numbers: the starting position and the angle of the needle. And then I would need to test while the needle touches a grid line. And we're going to do it 10,000 times. So we're going to agree at the lower point of the needle. That's where we're going to start. We're going to force the computer to do that. The x-coordinate is irrelevant, and you may assume its y-coordinate, y low, to be any random number between 0 and 2. However, because it's a floating point, we use the next double method, which returns a random floating point between 0 and 1, and then I multiply it by 2 to get a random number between 0 and 2. The angle, alpha, between the needle and the x-axis can be any value between 0 degrees and 180 degrees. Alright, so I'm going to then have an angle of 180 times generator.next double. And we're going to loop this 10,000 times. Alright, so I got my needle constructed, hits and tries is 0. I got my generator initialized. I'm going to drop. Alright, so my low x value needs to be between 0 and 2 on my number line. And then I create an angle of between 0 and 180 by multiplying this up to my next double amount. Then I calculate where the tip would be, the high end, which is my low plus the side of this right angle that we're generating with the needle. And then we get the number of times if y high is greater than or equal to 2. That is, we hit twice or 2 inches above our line. We increment the number of tries, or sorry, we increment the number of hits, and then we always increment the number of tries. Then I just return that. So my loop is going to be in the needle simulator. I'm going to call drop 10,000 times. Whoops. So final int tries 1 is 10,000. Final int tries 2 is looks like 1,000,000 times. So for int I equals 1, I is less than or equal to tries 1, I plus plus, drop my needle. So I made my needle and I dropped it. Print. Now the number of tries. Then I'm going to run it a little bit more. I'm going to run it from 10,000 to 1,000,000 times, and I'm going to drop it. I'm going to print the number of tries divided by hits, and I'm going to print out my tries, the double, get tries, and get hits. So when I run it, so notice there's a little bit of pause 1,000,000 times. It does take actually a little bit of noticeable time. 10,000 didn't do it. Tries divided by hits equals 3.18. We're looking for 3.1415 as an approximation of pi. I run it 1,000,000 times, I get 3.14. and the time before I got 3.19, so it's actually actually pretty close. So we'll run that one more time, so look for that pause. Alright, so it's going to flip up to 10,000 right away, and then the million's going to pause out. Put a bit of a pause before it shows up, because it's actually will take some time to run something this long. So all you need to know is a double is going to give you values between 0 to essentially 1. So whatever your range is, you need to multiply that number by that range. So my low value is between 0 and 2, so I use that, and my angles could be anything from 0 to 180, so I run my next double times that value. Remember, an int goes 0 up to the number n, parameter n, but not including it, so either have to go one more. If I wanted 0 to 6, I'd have to put n equals 7. But if you want, let's say, 1 to 6, then I can put in 6 and just add 1 to it. But you do also need to remember that it always starts at 0.